Hello. All right.
Everyone would know it's you, though.
Yeah, it's still no. OK, let's kind of go through this real quick. I'm just going to kind of go through, again, the steps as far as writing the equation. So like on your quiz, what I told you guys to do when you have to write the equation, plot the information. Just plot the information. So you guys are given foci. Now, that doesn't look like very fun to plot, right? But we can estimate that. And that's all you need to do is just estimate that. So estimating that, again, I know that the square root of 1 is 1, and the square root of 4 is 2. So the square root of 3 has to be between 1 and 2. Would you guys agree with me? Yep. Just estimate. That's all we need. Now, again, that's 0, comma, plus or minus square root of 3. So that's going to be going up or down. So my two foci are right here. Now, automatically, just by doing that, that tells me so much about this ellipse. One, I know the center is directly in between my two foci. So do I know where my center is right now? Perfect. 0, 0. Just by plotting that, I now know my center, which is 0, 0, which is hk. The next thing is I need to determine, is my major axis vertical or horizontal? Is it being elongated horizontally or vertical? Vertical, because the foci and your vertices lie on your major axis. So I can see that this is my major axis, so I'm just going to label it so I don't forget. That's major, that's minor. OK? That's all important because now, do I know what the general equation is of my ellipse? Yes. It's going to be the one where a is under the y. So I have x minus h squared all over b squared plus y minus k squared all over a squared equals 1. Right? So now I just need to figure out what a and b are. So I did give a vertex, which is 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the one thing, guys, to remember about an ellipse, which remember those pictures I showed you? If you have a vertex up here, that means you have to have a vertex down there, right? If you have a covertice here, you have to have a covertice there, right? So if here's one vertice, if I go up 10 to find one vertice, that means I have to go down 10 to find my other vertice. Now, but in reality, guys, we don't really actually even need to know that. I just did that so you guys can see that. What do we really only care about? We only really care about what is a and what is b. The distance from the center to one vertice is a. That's all I really needed. So I really didn't even need to do that. I was just doing that for kind of instructional purposes. So I know a is equal to 10. That means a squared is equal to 100. Now we need to figure out b. Well, the problem is we know what c is. That's square root of 3, right? The distance from the center to the foci, not the center c. The distance from the center to the foci is square root of 3. So again, we go back to our formula. C squared equals a squared minus b squared. C squared is the square root of 3 squared equals 100 minus b squared. Oops, let's just do 10. We already said it was 100, right? Square root of 3 squared is going to be 3 equals, why did I do it? OK, 100 minus b squared minus 100 minus 100. Negative 97 equals negative b squared. Divide by negative 1, divide by negative 1. 97 equals b squared, square root, b. Oh, why am I doing that? Don't need to go that far. Guys, all we need is what? B squared. We don't care what b is, at least for this problem. We just want to know b squared, and we want to know a squared. No, because I divided by negative 1 on both sides. It's negative 97 equals negative b. What? What doesn't make sense? Where did I lose you? It is.
A is 100. A is 10, but a squared.
So now we just type it in. So x, you guys are OK if instead of saying x minus 0, I just say x squared. Is that OK? So therefore, I have x squared over b squared, which is 97, plus y squared over 100 equals 1. OK? Anybody want to